Okay, so here we're going to look at cycloalkanes, and the cycloalkanes are a type of alkane, okay, as I say in the word, they're alkane, which means that they're also single bonds, and what they are is they are rings of single bonds, okay, they're really easy to name. All you do is you put the prefix cyclo to whatever the parent chain is. If it's off a longer chain, I'm going to put that in there, if it's off a longer chain, so that would mean that it would be a substituent. That means then that you put it as a YL ending, but still needs the cyclo prefix. So you're going to have some examples here I'm going to draw. You're going to have like a cyclohexane, a cyclopentane, and a cyclopropane. So I'm going to draw some examples. So if I have cyclohexane, so you have cyclohexane, which is 6 sides. It's kind of like these line structures that we talked about earlier, where each kind of corner is a carbon. Okay, then you're going to have cyclopentane, which is going to be 5. So you're going to have a 5-sided item or shape there. You're going to have cyclopropane, which is going to be 3. So they're going to look like a triangle. You can have cyclobutane, which is going to be 4. Okay, so notice how they're all these rings of these bonds, and they're all single bonds, which is why they're only one line there. Okay, cycloalkanes with fewer than 5 carbons are strained due to their small bond angle. As your rings get smaller, the amount of strain increases, and so does the reactivity. So you don't really honestly see either one of those two, the cyclopropane or the cyclobutane. Okay, these are way too reactive. All right, so let's look at an example here of methyl cyclopropane. Okay, we have a cyclopropane, so that's going to be the 3 here. So that's the triangle. And I have a methyl group off of it, so it's methyl cyclopropane. You can draw it out with the C's and the H's if you want to, or you can just put the shape. Okay, I don't have to put a 1 here because 1s are kind of assumed if there's nothing else. All right, if I had another group here, all right, then I'd have to put 1,2-dimethyl, but I don't have another group there, so I don't need it. So now I'm going to name a couple of cycloalkanes. So the first thing I'm going to do is count how many are in your ring, and is it the longest chain, okay? So I've got a ring here, it's a ring of 4. Well, 4 is longer than this group of 2. So this is going to be a cyclobutane. So we start out and say, okay, I'm going to be cyclobutane, all right? Now what's off of my cyclobutane? Off of my cyclobutane is an ethyl group, because there are 2 carbons here. So we're going to be ethyl cyclobutane. Now again, I don't need to put the 1 in there because it's only one substituent, and it doesn't really matter which end it is off of. All right, now let's look at the next one. All right, let's count up how many we have there. All right, we've got, starting here, I got 1, 2, 3, 4, 5, 6. So this one here is going to be a cyclohexane, because there are 6 sides. There are in a ring, so it's cyclo, it's ane, it's single bonds. Now what do I have? I have 2 methyl groups. So I think, all right, I'm going to have a dimethyl. Okay, so dimethyl. Now I need the numbers for these methyls. Now it really doesn't matter. Any way you go, I can go 1 on this guy here, 2, 3, or go 1, 2, 3. It doesn't make a difference. It's still going to be 1, 3. So we go 1, 3, dimethyl cyclohexane.